This is 6.5 graphs of the other trig functions. We've already graphed sine and cosine, and it's all based on the unit circle. So a couple things to remind ourselves about. Every single point on the unit circle, every point is made up of cosine then sine. So the first coordinate of every single point, that is cosine, then sine. Cosine, then sine. Also, remember the sine function. If you go around and collect all of the sine functions, all of the sines, so the sine of 0 degrees is 0. So that's where I graph that. The sine of 90 degrees is 1. So at 90, it's right here at 1. And then you paid attention primarily to 0, 90, 180, 270, and then 360. And you could graph all the other points if you want. Those would be on the graph. Okay, those would be on the graph. But you primarily just need to pay attention to the 90, 180, 270, and 360. And then likewise for the cosine. So the cosine, you're going to graph the cosine, and notice the cosine starts at 0 degrees. It's at 1. So that's why we start right there. There's the starting spot. Okay, and then you can graph all the other ones, and you can see the function. Now, what I graphed was one period, and again, just to remind yourself, it does, because the unit circle, I can go 2 times around, 3 times around, I can go negative, so this graph actually keeps going, forever, and keeps going this way forever. Same with the cosine function. All right, so that's, we reviewed that in the last lesson. If you need to go back and watch the last video, 6.4, go ahead and do that. Now, let's graph the tangent function. So a couple things to remind ourselves. Tangent is sine over cosine. So if I kind of walked around and looked at 0 degrees, and then 30, then 45, then 60, then 90, and then just primarily stayed with the bigger degrees that I told you last time. So sine of 0, or tangent of 0 is sine of 0 over cosine of 0. Well, the sine of 0, and again, as a reminder, a point, the xy coordinate. So the first one is cosine, the second one is sine. So the sine of 0 is 0, the cosine of 0 is 1. So 0 over 1 is 0. Remember, 0 on top is 0. And you can go through the thing, the tangent of 30, tangent of 30 is the sine of 30, so this is 1/2. Divided by the cosine, so the square root of 3 over 2, which again, I told you the denominators, if they ever match up, you can just kind of cross it out, so it's 1 over the square root of 3. You can't have a square root on the bottom, so you're going to multiply by the square root of 3 over the square root of 3, so this is square root of 3 over 3. So the tangent of 30 is the square root of 3 over 3. The sine of 45 divided by the cosine of 45, well, notice these are the exact same numbers, so that's just 1. The tangent of 60 is going to be, again, sine of 60, so the square root of 3 over 2, and then divided by the cosine of 60, which is 1/2. So this is just going to be the square root of 3 over 1, or just the square root of 3. Now, look at the tangent of 90. The tangent of 90 is the sine of 90 degrees, which is 1, divided by the cosine of 90 degrees, which is 0. You cannot have 0 on the bottom. This is very important to realize. I'm going to highlight that because it's undefined right there. Likewise, when we go to the major things, when we get tangent of 180, sine of 180 would be 0. Cosine of 180 is -1, so this is 0. Tangent of 270, again, sine of 270 is -1, and then divided by cosine of 270, which is 0. Notice this is undefined as well. Very important to realize that. And the tangent of 360 is the same as tangent of 0 degrees, so you're going to get 0 on that. So notice what we have here. We have some important points to realize, and now we're going to take those values and we're going to graph them on the tangent. So notice, so when we start graphing the tangent function, I want you to just recall what we just now wrote down. All right, so notice specifically these two that we wrote down, and a tangent of 90 degrees, there's actually, it's undefined, so the tangent function can't happen there, so there's actually a vertical asymptote at 90 degrees, and again at 270, and again at 450, and at negative 90, at negative 270, at negative. So basically every 180 degrees, it's undefined, and notice what happens between those things. So the tangent of 0 is 0. So halfway in between there, we're going to get 0. Now, I did write one more point in there just so you can understand what's going to happen. So the tangent of 45, so 45 is right here, and notice it goes up to 1. And negative 45 would actually be down at negative 1. So this graph is going to look like a cubic function. Remember a cubic function? It looks like this. So it's going to look like a cubic function. So every one of these is going to look like this. So, by the way, this is one period right from here to here. This is one period. So, I actually did 5 periods of graphing the tangent function. But I wanted to let you know how I came up with the tangent functions, all of these. Notice I got undefined, and that's the vertical asymptotes. Now that you understand the cosine, the tangent, the cotangent is just the opposite. So, if I did y equals cotangent, so it's going to look very similar to this. So you're still going to have 90 degrees. I'm just going to do one period. And those are going to be vertical asymptotes again. Let me back that up real quick. So if you notice, I meant to do 2 slashes here. If you notice what's going to happen on cotangent, you remember how did we get undefined? It's when you can't have 0 on the bottom of a fraction. So if you go back and look at it, cosine, sine, when will that be on the bottom? When will cosine be on the bottom? Because if we did tangent, remember tangent is sine over cosine, and then cotangent would be cosine over sine. So you can't have sine on the bottom being 0. So where is that 0? Well, notice at at 0 degrees, at 180, at 0 and 180 is where it's going to happen when you have the sine of 0. So again, if you wanted to make a chart up, you can real quick. Again, cotangent. Let me just do cotangent of 0 degrees so you'll see what I'm talking about. So this would be cosine over sine of 0 degrees. And cosine of 0 degrees is 1. Sine of 0 is 0. And so that's undefined. So notice you have a vertical asymptote at 0 and then at 180. So the same thing at negative 180. But it's going to look very similar. So again, the asymptotes on tangent is at 90 and negative 90, and at cotangent it's every 180 to be able to do that. But again, when you graph it, you're going to see it. It's going to look like this. And again, so I graphed 2 periods right there. So again, make sure you understand when sine, you cannot have 0 on the bottom. So when is sine, sine of what will give you 0 on the bottom, and that's going to make it undefined. So that's why it goes, at 180 and 360 to be able to do that. All right, so let's talk about the other 2 functions. So let's talk about y equals cosecant of x. So how do you graph that? And then y equals secant of x. So how do you graph those? Well, just as a reminder, cosecant is the same thing as 1 over sine. Okay, so it has something to do with the sine function, and this is the same thing as the 1 over cosine of x. So it has something to do with the cosine function. So let's refresh our memory on what the sine function looks like. So the sine function looks like this. And remember, it goes at 0, 0, and then at 1, it's at 90, and back down to here. That's what the sine function looks like, the normal sine function. And again, likewise with the cosine function, so you have 360, 180, 90, 270, 1, negative 1. But the cosine starts here. Okay, so that's the normal sine and cosine function. And I want to remind you, you cannot have 0 on the bottom. So when is sine 0? Well, sine at 180 degrees, sine of 180 is at 0. And of course, sine of 360. And of course, sine of 0 is 0. So you cannot have at 0 degrees, it's going to be a vertical asymptote. So you're going to have a vertical asymptote. And at 360, because you can't have 0 on the bottom. You'd rather do that. Now, you remember the normal sine function is the red right there. So this is going to literally look like a parabola inside of that. And the same thing here. It's going to look like a parabola inside of there. But it's going to touch at that spot right there. So graph the normal sine function, and then you'll know that it literally used in the opposite direction. Again, the cosecant function is the reciprocal of the sine function. So graph the red, that's the sine function, but the cosecant is just the green functions. Okay, just the green ones. And the same thing with the secant function. So the secant is very similar, so you can't have 0 on the bottom. So where is cosine 0? So if you notice cosine at 90 degrees, cosine of 90 is 0, and also cosine of 270 is 0. So at 90 and at 270 is where it cannot have, you'll end up having undefined right there. So that's where you have a vertical asymptote. And again, the same thing. It's going to look like a parabola. And I'm out of space here, but it's going to look like a parabola right there. And again, the same thing here. If it keeps going on like this, so every 90 degrees, or from 90, so it's at negative 90, you're going to have a vertical asymptote. And you're going to have a parabola inside of there. And that's the secant function. So again, the way to remember secant is 1 over cosine. Graph the cosine function, and then it's the parabola, basically, on the inside of the vertexes at the inside high point of the cosine function. So that's how you do that. And again, the green is the function. So if I was asking you just to graph the secant function, you would not be graphing the red. Okay, so the secant function would look like that. It's just a bunch of parabolas inside of those asymptotes. The same thing up here. You would just be graphing the parabolas inside. So that's how you graph the other 4 functions. Again, it's all based on the unit circle.